record. Cool, we're recording. Okay, so let's pick back up from last week. So we ended last week by covering an example of collecting the data. Well, we covered a bunch of different packages that you can use to collect data for your projects, right? So you can look at unemployment rates across countries. You can look up, if you're interested in studying oil prices, you can use Quandl to collect data on oil production or on futures prices. And we also covered last week using collecting data from the Forbes website, right? Yes.
Yes.
So the link is not here again, so let me find it again. Okay, so this was the link we used. This was the link we used last week. Right? So we said if you go to this URL, you get this data that comes in this JSON format, where you have the person's, inside of the curly brackets, you basically have one row of data. And inside of the curly brackets, you basically have this key and value pair separated by commas, right? So here the key is name and the value is this. There's the key, there's the value, there's the key, there's the value, there's the key, there's the value, right? So the key and the value are separated by a full colon. Okay, so this is sort of the standard way that most data is shared between a server on the back end of a website and the actual front end, the stuff that a user would see. Okay, so we said that there's this package called JSON Lite in R that we can use to actually read in all of this data and parse it automatically for us into a data frame. So what R is basically going to do is it's going to go through every single set of curly brackets, and it's going to extract what the name is. And then it's going to stack all of those names on top of one another, and it's going to form a column. Make sense? Mm-hmm. And it's going to do the same thing for last name. It's going to do the same thing for URI. It's going to do the same thing for a bunch of stuff, for all these other columns. Okay. The point here is, I want you to know there's a type of format called JSON. So Tusa, when you're trying to collect data from the real world, right? This is a very nice way if you can find a JSON API to get a lot of data really quickly.
Right.
Okay. Okay, and I think where we ended last week was on this example, right? Collecting data from Wikipedia pages. So I gave you guys a link inside of that lecture. Where if you go to the link, it basically takes you to this page, right? Okay. And we introduced this idea of developer tools inside of your web browser, where if you right-click anywhere on your web page, if you're using Chrome, your little menu is going to look something like mine. If you're using Safari, it's going to look a little bit different. If you're using Firefox, it's going to also look a little bit different. But pretty much all of them should have an inspect or inspect element option that you can click on. Okay. When you click on inspect, it's going to show you basically all of the HTML elements or all of the hypertext markup language that makes up this web page. Right? And if you click on this little icon, In Safari, I think it's like a crosshair type of looking thing. If you click on inspect element, wherever you put your cursor, it's actually going to take you directly to the code that makes up that element inside of the web page. You guys able to do that on your own machines? Chandra, Roberto, Tusa? Okay.
Still working at it with Safari. There's a couple of things that I need to change on my browser settings to allow me to use it. I'm working on it.
Here's me on Safari. I think you have to go to like, I think in Safari you have to go to Safari Preferences. And then I think in General.
I think it's advanced.
Yeah, so in Advanced you have the Show Develop menu and menu bar. Okay, so you just need to have that clicked.
Yes.
If you're using Safari. So in Safari, if you right click, you can click on Inspect Element, and then you'll be able to see on the Elements tab all of the HTML that makes up the page. This is that crosshair looking thing I was talking about. When you click on it, it'll highlight for you every single HTML element. So if you click on something, it'll take you to the HTML code that makes up that element. Okay, so that's the Safari version. This is the Chrome version. Wherever you put your cursor in Chrome, it'll show you the actual HTML element. Okay. This is a really useful tool whenever you're trying to collect anything from the internet. Because basically you can imagine a program that you write that says, go to this web page, find this element inside of the web page, whatever that element is. You'll have basically a way of finding it. Okay. So here we have, on this web page, there's this thing here that looks like a table, or it really looks like an Excel sheet. If you move around your cursor, you'll see that this is actually a table. It's a table object inside of the HTML language. Okay. Inside of this table, there's a header, T head, and what's inside of the T head column or row is basically all of this information. See that? Okay, then there's a body, and inside of the body, there's a bunch of rows. TR, table row. Inside of the table row, there's a bunch of elements. See it? Okay. So one thing that'd be nice for us to do is write some code to be able to go to this website, gather all of the HTML, go through the HTML and find the table and table elements and extract the content for us. So this, Atusa, is like a way of really getting practice with, dealing with real world data. Okay, so let's go back into R so we can start actually doing that. Okay, so I asked you guys last week to add in another package, rvest, R-V-E-S-T, and you guys should have installed those 3 packages last week. Yes?
Yes.
Okay. If you load in the XML package, load in the HTTR package, we're going to define URL as the link to that Wikipedia page. Okay. First step we're going to do is we're actually going to go to the web page and we're going to extract all of the HTML. We can do that using the get function. The get function is going to go to that page and it's going to get all of the content for us. Okay, so if we run this little bit of code, we should see a new object appear inside of our global environment. So here we have HTML data, it says it's a large response and has 10 elements. We have the URL address of where we did the GET request. We have a status code. Here it says the status code is 200. Does anyone know anything about HTML status codes?
No.
Yes, 200 it means okay, good.
Yes.
400, 404 it means not good.
Yes.
502 means bad.
Yes. So 200, thank you, Tessa. So 200
That's what I do, sorry.
You're good. So 200 means you have a successful response. Okay. So we can always check the status code. So if you do HTML data $status code, that'll tell you basically the HTML code or the status code that was returned by the server. 200 means we were able to successfully make a query. 400 or 401 or 404, or pretty much anything other than 200 usually means there's some error that occurred. Okay. The codes themselves usually have a meaning, so it'll tell you or help guide you to what the error that occurred actually is. Okay. So one thing we can do is we can go into the content. So if you do HTML_data $content, that's going to return for you a bunch of, oh no. Oh no, we're good. Okay. If you do HTML $content, it looks like it's just giving you a bunch of numbers. Okay. These numbers are basically the encoded response that was retrieved from the Wikipedia page. As humans, we don't know how to read this data. So what we can do is extract the content from the HTML data in the format of text. And what that's going to do is actually parse all of the HTML text for us. That is pretty much all of this stuff, exactly as you see it here, and present it to us in a readable way. So here it's basically going to preview or print out all of the HTML. And here it is. Okay, so in all of this stuff that's in here that I'm scrolling through, this is all basically the web page that makes up this page we were just on. Okay, and if you scroll through here, you'll start to see some stuff that looks kind of familiar. Here, see this? Global Industry Classification Standard. It's going to be hard for you to find exactly where I am, right? But if you're just scrolling through the table, you'll start to see stuff that looks familiar. Here we see 3M, MMM, right? You see that? So inside of all of this crap or all of this text is basically the content that we really want. Okay. Now, the XML package actually has a really useful command for us that is able to take in HTML code or responses like this and convert it into a table. Specifically, it's going to go through all of this HTML code and it's going to look for these things. A tag that starts with the word table. And it's going to go through and extract all of the content inside of the table tag. Because if you click on these little arrow icons, you'll see that the table basically makes up all of this information. All the information is inside of that one table tag. Okay, so we can try using this read HTML tables function. When we run that, we'll see we have this new object now called wiki tables. So wiki tables says it's a list of 2. Read HTML table is going to go through the HTML of any website, and it's going to extract all of the tables on that website. All of them. Here it's saying there's a list of 2. That means read HTML table found 2 tables on this web page. Okay. Here's the first table. If you keep scrolling down far enough, you'll see that there's actually a second table on that web page. And that second table is basically a list of companies that were added to the S&P 500 and companies that were removed from the S&P 500. And again, this is just an index that tracks the 500 largest companies in the United States. So here it's saying Macy's on April 6th recently was actually dropped from the S&P 500. Okay, so our code here, this read HTML tables thing, returned two elements, which is a list. Okay, and again, a list looks something like this, right? The first element of the list is going to be our companies in the 500, largest companies. The second element of our list should be the companies that were added or removed from the index. Okay? Make sense? Okay, so if we do wiki tables,
And Haysom,
Yeah.
are we allowed to? Is this like legal to do for like all websites, or is this only publicly traded websites, or is it like
gray area.
gray area? Okay, cool. I love it.
It's totally a gray area. Okay, so if you do wiki tables with a 2, you'll be able to extract the second table. So here it is. We can see the dates for when a company was added or removed. So there's that Macy's information we were talking about. If you do head wiki tables 1, we should be able to see the companies that are inside of the S&P 500. Okay, and Joseph, I'm actually glad you asked that because it is really a legal gray area. Okay, it's a gray area because a lot of companies will allow you to collect data or web scrape from there, and a lot of companies will explicitly say, no, you cannot web scrape from us. The truth is, though, the internet's kind of like the Wild West. So kind of everything goes until you're caught. From my experience, what I would recommend is you can collect data from the internet, just don't abuse it. By that, I mean, it's okay to use this data for like your own private use, but don't try and like collect a bunch of data from Wikipedia and then go try and sell it, for instance. That's not cool. Or to basically, here, every single time I'm doing this GET request, I'm basically making a query to their website, right? What if I wrote a parallel loop where I'm simultaneously querying their website 10,000 times a second? Their website might crash.
That's what hackers do.
Right, and it's a form of terrorism, right? So it's called the distributed denial of service attack, or a DDoS attack, and that's actually something you can do to try and shut down a website. It's kind of hard to do nowadays, but it's doable. Okay, so you need to be very careful with how often you query a data or query a website. Does that make sense?
I think they're really good websites, like the Fred one. You can tell when you're querying back their system in R. If you hit more than, I think, 5, they hit 1 at a time, right? Am I right, Hassam? They say like retrieving the first one, retrieving.
So that's actually something the QuantMod package does. So the QuantMod package allows you to pull, we covered the QuantMod package as a source for you to pull information from. And we said you can actually pass in multiple symbols at a time, and what it'll do is it'll automatically just go and get all of that data for you. The QuantMod package implements exactly what I'm saying. It builds in a time delay between the queries. It's actually not something from Fred. It's something the QuantMod writer, the package writer, implemented in order to stop you from doing a DDoS attack unintentionally.
Good to know. Thank you.
Make sense? Basically, don't query the crap out of a website. Make sense?
Got it.
Good. Okay, so be nice about it. Anyway, this is what our data looks like. So if we do head wiki tables 1, that's actually what we want. This is the S&P 500 companies. It's not exactly in the correct format that we want though, because here it's saying the column names are V1, V2, V3, V4, etc. In reality, the column names are actually the first row, right? So here the first row, symbol, security, SEC filing, these should be the column names. These aren't actually objects we care about, right? What we actually care about is like 3M or Abbott or AbbVie, right? So what we can do is rather than deal with the list, we can actually just extract that one element of the list and call it SP companies. Okay, so if we do head SP companies, that's going to be just the data set that we care about. So we can ignore the second table that we collected of the companies that were added and the companies that were removed. Okay, again, this is just an example of using read HTML table for S&P 500 companies. You can use read HTML table for any company, or I'm sorry, not for any company, for any HTML table on any website, anywhere. Okay, so hopefully in a minute we'll take a break and you'll be able to actually go try and collect an HTML table from a website. Okay, anyway, if we look at this data we have now, we can look at one of the columns. Let's say we look at this first column, or the second column, V2. So if we do SP underscore companies $V2, that'll allow us to access the second column here. So if we run that, we're going to see that our results are actually printed out as what kind of variable prints out for us this thing, a level at the very bottom? Does anyone know?
Is that a factor variable?
It is. So in R, there's a memory reduction technique that's used. And the memory reduction technique works like this. Instead of saving a word over and over and over again, you can save a numerical representation of that word in order to save memory. So the classical example is, let's say I have two words, boy and girl. Okay, and let's say my data set looks something like this. The first entry is boy, second entry, or boy, girl, boy, boy, girl. Okay. So let's say this is my data set. Here I'm storing 1 character, 2 character, 3 characters. Here I'm storing 4. Here I'm storing 3, 3, and 4, right? Rather than me storing the entire word of boy, or rather than me storing the entire word of girl, what I can do is have boy be coded as 1 and have girl be coded as 2. So then everywhere I have a boy, I'll just write 1, 1, and girl is 2. So basically then all I have to store is a vector of numbers, 1, 2, 1, 1, 2, and then I have to store a table that says boy maps to 1 and girl maps to 2. By doing this, I save the amount of memory or the amount of characters I have to actually keep in memory. Make sense? So rather than storing 4 characters, I just store one number, 2. Rather than storing 3 characters, I just store one number, 1.
Sounds good.
So it doesn't seem like I'm saving much here in this example where I have 5 entries, but imagine I have 10 million entries, right? Then I'm saving a lot of space. Okay, so factor variables are a numerical representation of words. And that numerical representation is also going to be useful in a regression context. Because if you have a factor variable in a regression, it'll automatically convert the factor variable into a dummy variable for you, or a binomial, or a 0-1 variable for you. Make sense? Okay.
It does it automatically?
It'll do it automatically for you in an if you use when you're using the LM function, if you have a dummy variable, it'll automatically turn it into. If you're using the LM function, if you have a factor variable, it'll automatically convert it into a categorical or a dummy variable for you.
Okay.
Okay, we'll see
Thank
that a little bit later. Anyway, the way you can tell if something is a factor variable or not is you'll get this thing, 506 levels, for instance, or 2 levels. It'll tell you basically that, remember that table I was just talking about, where 1 means boy and 2 means girl? Whenever you see this thing levels, it's basically telling you that there's this table that's stored, okay? Whenever you have something actually stored as a character, it should be in quotes. Here there's no quotes, and we have this levels, which means we have a factor. You can also check by running the class function on the object of the vector, and it should print out for you factor. Okay, so the object class is a factor. What we really want to do is convert it to a character, because we don't have more than one company entered more than one time here. So there was a mistake when the data was read in, right? 3M only appears one time in this data set because every row is a different company. Make sense? Because of that, it doesn't make sense for any of these columns to be represented as a factor. They're only entered one time. So what we can do is loop across this data that we collected and convert it from a factor to a character. Okay, so this is some of that like real world messiness. This XML function has this nice read HTML table command, but at the same time, it converted everything into a factor variable for us. We don't want it to be a factor. So what we can do is loop across and correct it and make it a character. We can do that using the apply function. Right, so we've talked about apply before. Apply can take in a matrix or a data frame object, and it can go row by row or column by column. Column by column is a 2, row by row is a 1. And then it's going to apply a specific command to each row or to each column. Here we're going to apply the as.character command to each column of SP companies. So we're going to coerce every single column from a factor to a character. Make sense? Okay, again, this is like the real world messiness you're actually going to deal with. Okay, so if we preview the data set now, we should see that there's actually quotes around every single word, telling us it's actually a character. Okay. There's some more messiness we have to clean up. Remember how I said before, this first row is actually the column names? Do you see that? So what we can do is assign the first row to the column names, convert the whole thing to a data frame, remove the first row, and what we'll end up with is a clean version of the actual object that we want. So now we have symbol as the column name, security as the second column name, sec.filings is the third column name, etc. And each row is now correctly formatted. Okay. Remember how we said QuantMod, for instance, has this get symbols function where you can collect stock price data?
Yes.
Well, I can do get quote is another function on the SP company's symbols, and that's going to get me the current price. Whoops, I need to load in the QuantMod package. So get quote will get me, let's say, the first 10 symbols. It'll go and actually get me the real-time price of all of those securities. There we go. Okay, so here's what we did. We went and we web scraped a table from Wikipedia. We cleaned it, and then now we can pass it into another function, like get quote from QuantMod, which is actually going to go and get us the latest prices for every single one of those securities. So I know we're covering each of these things separately, but I want you to start thinking about them as actually, how can I maybe, write this manual script to go and collect some information from one place and then feed it into a different command that's already built into another package to go and collect the data from there. Make sense? I know, we're covering a lot. Okay, here's what I would like. I want you guys to create a new R chunk. Okay, create a new R chunk. And we're going to take a little break right now for like 15 minutes to 2:30. And I want you guys during this break to try using this code or try modifying this code to collect and clean a Wikipedia table. So go to another page on Wikipedia, look up another table on another Wikipedia page, see if you can web scrape it. Sound good?
Let's try.
Sounds good.
Tusa, good. Teo, good. Joseph, good.
Good.
Let's try.
Dana, good. Okay, so let's take a little break for 15 minutes, and then we'll pick back up, and we'll have you guys share what you were able to collect. Sound good?
Good.
Good. 15 minutes, I'm going to randomly call on some of you, so have something ready. And, okay, so the next thing in the lecture that we have is essentially an example. And the example walks through going to a Wikipedia page and collecting a bunch of mental health disorders. So let's jump back into R. Okay, so this example that I've put together for us is sort of a multi-step thing. The first step is going to this URL, list of mental disorders. If you go to this web page, it's basically going to show you a bunch of different types of disorders that are known, right? You might have acute stress disorder, you might suffer from alcohol abuse, which is on the rise thanks to COVID-19, alcohol dependence, alcohol withdrawal, etc. There's tons of stuff, right? And here it's all sorted alphabetically. So you can see that there's tons of different disorders that someone might have. Okay. As we were able to read in HTML tables, this data is actually another form, or is another structure that is embedded inside of an HTML page. Specifically, if I right click on the page again and click inspect the same way I did before, if I use my cursor again to highlight over each one of these different disorders, I'll see that these are actually all wrapped inside of an LI tag. An LI tag inside of an HTML page is called a list element. Okay. UL is an unordered list. LI is a list object inside of a UL tag. Okay. The XML package has another function called read HTML lists. So similar to read HTML table, there's read HTML lists, and read HTML lists can go through and extract all of these different list elements for us. Make sense? Okay, so that's all this code is doing. It's exactly the same as before. We're going to define URL as the website address. We're going to get the HTML content from that page. So we're going to do a GET request. We're going to parse the information that was retrieved as text using the content function that was inside of the HTTR package. Instead of using read HTML table, we're going to use read HTML list. Same thing as before, except now it's list instead of table. Okay. What we'll see now is we were able to retrieve 42 different lists. So Annie was saying, how do I know which object is the correct table, right? With your GDP example. Here we have basically a bunch of different lists. This is one list. So all of the A's are basically one group. See that? What the read HTML lists command is going to do is it's going to find all of these UL tags inside of the code. And it's going to go through and collect every single one of them.
I see.
Okay. So if we do WikiList 1, the first thing actually we're going to get is the alphabet, A, B, C, D, all the way up to Z. Where did that come from? Ah, here, table of contents. The table of contents is a bunch of list elements. See that? LI, 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 they're all just different list elements. So that's the first element we collected. Okay, how about WikiList 2? That looks like all of the A's. What's Alice in Wonderland syndrome? Anyway, that's all of the A's, right? How about 10? That's all of the L's. How about 19? A list of neurological disorders. Okay, how about 20? 20 looks to be blank. Okay. Maybe 18. Probably 18 is the last one. So if we scroll through here, it looks like 18 is actually the last one. Undifferentiated somatoform disorder. I'm not good with these words. Okay. So here in the code I had written previously, WikiList 2 to 20. Let's change that to 2 to 18. Okay. So what we're going to do is, here we have a list structure, right? Again, it's like this little tree thing. We have the main branch, or sorry, we have the main trunk, and then we have a bunch of branches coming off of it, right? This thing here, the main trunk, is called WikiLists. And inside of there is all the different disorders, right? Here's the A disorders, here's the B disorders, and then there's tons of other stuff, right? Really what we care about is only the first 18 elements. Specifically, we don't even want the first one because the first one had just the alphabet, right? It was like a table of contents. So what we're going to do is grab the 2 to 18 branches. So grab branches, there's branch 1, there's branch 2, branch 3, all the way up to branch 18. And we're going to unlist all of those branches. That is, we're just going to combine all of them, all of their values, into just one giant vector. Make sense? So here we now have basically a vector that contains 166 different disorders that are listed on the Wikipedia website. Okay, so it's pretty similar. Instead of read HTML table, it's read HTML list. It returns everything as a list object. It's your job then to go through that list object and decide what information you actually want to keep, what information you don't want to keep, and then you need to clean it up into a certain way where it becomes usable for you. Here it's usable for me in the sense of it's all just in one vector for me, so it's easily accessible. Make sense?
Excuse me, hi sir.
Yeah.
Should we make sure that the dimension of every list is the same, or just combine the list like that?
Here it's not gonna. Here it doesn't really matter. So here we're just combining everything into one vector. So we're just sticking everything together into one giant vector. So whatever. So if the first list has 7 elements and the third one has 4, it's okay because I'm just stacking them all next to each other. Make sense? If I was actually stacking them like matrices or data frames, then I need to make sure they have the same dimension. Here they all have the same dimension. They're just a vector of 1, right?
Okay, thank you.
Yeah, but yes, you do need to worry about the dimensions lining up, but here it's just a bunch of vectors, so we're just going to concatenate them all together. Make sense? Can I get like a thumbs up or something? A digital thumbs up, a Zoom thumbs up?
It makes sense.
There we go. Okay. Okay. Another website that's available, and actually that's something you guys can use for maybe one of your econometric projects, is this really nice little website, which actually makes it publicly available for you to see how many times someone goes to a Wikipedia page. So here I've put a link for you guys. If you just copy that link, should take you to this article. Okay, and this article basically shows you or describes for you how you can access page views for Wikipedia. Okay, the second link is actually the one that you want to go to, sorry. And this one will show you basically how many times the page cat and dog have been viewed on Wikipedia. Okay, so if I look up the word cat, for some reason there was a lot of people looking up cats, the Wikipedia page cats, on March 30th, and then now there's not many people looking up cats. Okay, here I can adjust, maybe like say the last 90 days, there we go. And so as I adjust this content, the charts are all updating, right? Okay, what's another page we can look up? How about we look up one of these disorders that we collected, right? So how about we look up acute stress disorder, for instance. Okay, so if I type acute stress disorder, if I run that, we can see how many times acute stress disorder has been looked up in the past 90 days. Okay, or I don't know, maybe I'm interested in a particular company. Maybe I'm interested in the S&P 500. Remember that? Remember how we were talking about this financial index? Okay, here's how many times people look up the S&P 500 page per day over the past 90 days. That's a lot of data, right? And this is time series data, so we can see basically over time how many times people have gone to this web page. This is a gauge for us for interest. Okay, and there's actually been some cool papers in the finance literature where people found predictive power with Wikipedia page views on financial market returns. That is, as people look up financial markets or securities more, it tends to be predictive of what's going to happen in their returns. Okay, now, wouldn't it be nice if we could just extract this information? I mean, here there's a download icon, right? And we can click CSV and then it'll download an Excel file for us. Or JSON, JavaScript object notation. Remember that thing? You can download JSON data. Okay. Well, it turns out, actually, there's another thing we can do. If you right-click on the page and click on Inspect, okay, you'll get your developer tools again. Doesn't matter what browser you're using. When you have your developer tools open, before we were using the Elements tab. When we use the Elements tab, we were able to see all of the HTML that makes up a web page. Okay. Turns out web pages are actually made up of really three things. Web pages have, or usually they're made up of three things. They're made up of HTML, which is sort of these base objects that we see, like text boxes, paragraphs, headers, tables. That's usually what the HTML is composed of. There's this other thing over here called styles. Okay, styles is another language called CSS. And CSS basically contains all of the formatting for the HTML. What type of font do I want to use? What background color do I want to use? Okay, that's all inside of sort of how I want the HTML to look. There's another thing called JavaScript. JavaScript's actually it's a different programming language, okay? But JavaScript is actually used, you can use JavaScript to create apps, you can use JavaScript to create interactive elements inside of web pages, okay? Chrome can actually show you a command line console for JavaScript. If you click console, you'll be able to see a JavaScript console. Okay. What I want you guys to do is use inspect, click on console, and let me know when you're there. Good. Give me my digital thumbs up again. That works. Okay. So I take it you're all there? Okay. What I want you guys to do is if you're using Chrome, I want you to click on Clear Console. That's going to erase everything from the console. Okay. I want you to click on this little gear icon or the settings icon. And I want you to make sure that you have this thing, log XML HTTP requests checked.
Oh, I'm sorry, you said we had to clear the console?
Yep.
Is that right?
Yep.
And
Which
just
is
the trash can?
in here.
Gotcha.
Okay.
And now I'm on Firefox. What?
Okay. Let me open up a Firefox browser. So I can do inspect element. I'll click on console. On console, I'll click on the little trash icon. Okay. Now in Chrome, I want you to click on this little gear icon. And in Chrome, I want you to make sure it says log XML HTTP requests. You need to have that checked off. Okay. Make sure it's checked. In Firefox, let's see. You should have this XHR and requests. Just click on them to make sure they're highlighted.
Thank you, Hazen.
Okay. Anyone else? No? Okay. Now, what we're going to do is literally just refresh the page. Uh-oh. There should have been for us a GET request inside of our console. Interesting. It's not showing. How about on here? Yeah, okay. So for some reason it's showing on Firefox, but it's not showing on Chrome. Oh, I had hide network clicked. So make sure you have hide network unclicked. Stupid. Okay, so again, if you type in, let's say S&P 500, or actually that's a good one, look up Spanish flu. Okay, so again, these are the settings you want to have in Chrome. You just want to have log XML HTTP requests clicked, and you want to have hide network unclicked. You should be seeing these GET requests happening on the JavaScript console. Do you guys all see that? Can you give me a thumbs up to make sure it worked? Sorry, I messed that up. Annie, good? Roberto, good? Francis? Kendra? Good? Okay. Now, what we're seeing here is basically every time we're looking something up, we're sending a GET request the same way we did in R, but we're doing a GET request using JavaScript, and it's happening for us automatically whenever we look something up. So when we look something up, what this Wikipedia page is doing is it's doing a GET request to a server, and the server is responding with some content. Okay. What Chrome or Firefox is doing here is it's logging for us all of the networking or all of the connectivity that's occurring in the background. So basically, we're interacting with the front end. The front end is being used to construct a query, right? I want to look up S&P 500 index, or I want to look up Spanish flu, or I want to look up the word cat. When that happens, it's going to construct a URL, and it's going to make a GET request, and then the server is going to respond with the information. That information is going to be rendered into this graph for us to see. Okay, so what happens if I scroll through here? I can see at the very bottom, there's this XHR finished loading GET. Okay, in here, if I right click on that link and I click open in new tab, I should see some data that looks like this. Okay, so it looks like the link I clicked on is actually rendering for me what it looks like the top 5 or top 10 ranking searches. Okay, so if I look somewhere on this page, there should be a top views here, top views. There's a top views tab. That top views tab is what's being rendered. Okay, what we actually care about though, whenever we do a search, so if I go back to Chrome, we don't really care about the top views. We looked up something specific. We looked up the Spanish flu in this example, right? Here I type Spanish flu. There's another GET request that was made a little bit higher up here. Do you see this GET request? Here I see the word page views per article inside of Wikipedia, all access user Spanish flu daily from 2020 01 to 2020 04. What happens if I click on that one and say open in a new tab? Here I actually have the JSON data that was rendering that graph we saw. That is, I have the page views for Spanish flu at this timestamp. There was 6,969 views. For this timestamp, there was 13,354 views. The point is, by using our command line tools inside of Chrome, we're able to intercept and see all of the GET requests that are happening from the front end, which is what we're used to dealing with as users, and the back end, which is actually processing and crunching all of the information. Make sense? So the front end is basically looking up information and structuring a URL. That URL then is being queried to the backend server. The server then is responding with information back to us to be re-rendered in a nice user interface for the user to see. But this graph, all of the information in this graph is inside of this GET request. Were you guys able to get there?
Yes, sir.
Okay. So this GET request that I clicked on, if we keep scrolling across, it's just JSON data. And I can actually take this URL that I have here, I can copy it, and I can paste it inside of R and do a GET request directly from R. So then rather than using the clunky user interface, I can just do a bunch of GET requests through R. And load in and process this JSON data using the JSON Lite package, the same way we did before. Okay, so here's an example of how we can do this. So I want you guys to notice something here. In my search that I typed here, I wrote Spanish space flu. Do you see that? Spanish space flu. In the URL that was rendered here, there's a couple of things happening. All of this stuff looks like, just standard stuff. That seems like it's their stuff, right? Here is actually the query that I wrote, Spanish flu. But it's Spanish_flu. The space I wrote here, Spanish space flu, was converted into an underscore inside of the new URL. Okay. That tells me something. Whenever Wikipedia is doing a query from its front end to the back end, it's converting all of the spaces into underscores. So if I want to automatically create these URLs to do let's say a lookup for all of these disorders I collected, I need to convert all the spaces into underscores. Okay, that's one thing. The second thing is, on this page views site, here I just clicked latest 90 days, right? See that? Latest 90 days, and it automatically calculated for me the latest 90 days. Okay. In this URL, it looks like there's a start date and it looks like there's an end date. You see that? 2020-01-20 to 2020-04-19, followed by 2 zeros. What if I change this starting date from not 2020 to, let's say, 2010? What happens then? It shows me Spanish flu data going back to 2015, 07, 01, all the way up to today. So it shows me then, day by day, for the past 5 years roughly, how many times people have gone to or looked up the Spanish flu on Wikipedia. Does that make sense?
Yes.
Okay. So what we're doing here is we use our command line tools. We see how the front end of a website is communicating with the back end. We intercept it using the command line tools. And then we try and be smartasses and manipulate the URL a little bit and see what happens. Make sense? Here, the smartassy part is changing the dates. Okay. Any questions?
How do you know what filters it has? So like those dates are filters, right? You just play around with it. You just continue playing around with the inputs and the website and then just examine the link to see how it's different.
Yep.
Okay.
So if you wanted to do this, for example, for something like, I don't know, like a Facebook page or something like that, right? How many times do people actually go through those things, right? I'm sure Facebook has that data, but if you wanted to get access to that, how could you do it? Because I know this would only work for Wikipedia,
Okay.
right?
So no, actually, there's a lot of websites, a surprising number of websites that do not secure. So Wikipedia is open source, right? It's known that they try and make their content readily available. So like we're not doing anything wrong by finding this hidden API for Wikipedia. Okay. But it turns out actually there's a lot of websites.
That's why it's here. It's here for free.
Yeah, it's here for free. Turns out that there's a lot of websites that have hidden APIs that it's just like poor security.
So it could be like there are certain things that you should be looking for in a website that would allow you to do this, right? Depending on how the website was designed.
You can go to the website. You can open up your command line tools now. You can refresh the page and you can see were there any GET requests happening. Rather, were there any unsecured GET requests happening? Okay.
Got it.
You'd be surprised as to how many websites you can go to where there's like all the information is just open. And it's not intentional.
Just poor website design.
Poor security.
Poor security. Now, have you heard of people ever getting
In trouble?
in trouble from this?
Yes.
Like, has the FBI ever started? Yeah. Okay, so you gotta be careful.
Of course. Look, the key thing is you don't want to abuse what you're doing. So, I mean, the John Hopkins data, right,
Mm-hmm.
that we're using for COVID, all of that is being collected with web scraping. They're a data aggregator. They're going to every single state and county's websites.
I see.
And they're collecting the information county by county. They wrote a program to go to every single county, and it just collects every day, right?
Wow.
So
Okay.
you can use your powers for good. It doesn't have to be for evil.
Perfect.
Right? Or, for instance, I use a lot of web scraping stuff for automating tasks for websites I pay for. So I mentioned to you guys last week, I work with an automotive dealership group. We have an auction website. Sometimes I'll automate our bids, or sometimes I'll automate our inventory management, or sometimes I'll automate lots of different features. I'm not abusing anything. They know what I'm doing, and I've informed them of it. So you have to be responsible about it. Okay. But yes, but look, technically it's a legal gray area. Like, it's not very clear. And there are ways to hide where you're coming from. So like you can bounce your URL address or your IP address from all over the world using Tor, for instance. So you'll set up Tor as a server on your computer, and then you'll use Tor as a proxy for your machine. And then you'll send your requests through Tor. And you're hidden effectively. Okay, that's for another day. Any other questions on this? It's important to know, right? Okay, so here now what we have is the ability to query page views for any Wikipedia page. Okay, if we go back into R, I've written out the instructions and put in images for you guys so you can see exactly how to create this. Here there is a loop that basically creates URLs automatically for every single one of those disorders we created. So there's this command called paste. And what paste can do is it'll basically take all of the elements of a vector and it'll stick basically text together. So it'll concatenate strings together. It'll merge the strings together into one string. So this is the base URL that we went to, right? Here's this first part, everything up to the word user. That's staying constant. The thing that's varying is the word after that. Then you have the word daily to denote the frequency. You have a starting date and you have an end date. Okay, what we have here in R is basically saying, I want to paste together that starting part all the way up to the word user. I'm going to paste in the main disorders, which is this vector of 166 different disorders, followed by daily 2010-01 all the way up to here it's 2019. Let's change that to 2020. 04 19. Okay, so let me send you guys all that latest version. Achus, are you able to get it going?
Yeah.
Cool. Okay, so I just sent you guys
It's,
all.
I think it's some kind of security on Google. It's a different, it's not the cookies in cookies.
Okay, well, you're cutting out a little bit.
I'm good.
Okay, good.
So what does the SEP extension mean here?
Sep is how you want to, it's the separator. So that is, here I have 3 strings. Here's the first string.
Okay.
Main disorders is the second string. And then this is the third string. The paste command needs to define how I want to stick these elements together. I'm saying stick them together by nothing. Separate, the separator is nothing.
Okay. So you can do without the separator?
You need to define a separator. Here I'm saying the separator is
before
nothing.
the column, yes, yeah.
Okay. So what we end up with then, if we do head all URLs, is basically a URL where this first disorder is plugged in. This here says acute space stress disorder, adjustment disorder, adolescent antisocial behavior, adult antisocial behavior, right, which I may suffer from, etc. Okay. Now, when we were looking up the Spanish flu, we noticed that all of the spaces were replaced with underscores. Okay. What we're going to do is replace all of the spaces that occur inside of this string with underscores. We can use the gsub command I mentioned a little bit earlier when I was talking to Annie about replacing commas to find any spaces and replace them with underscores inside of the all URLs vector. So we're going to go element by element of all URLs. We're going to check, is there a space? If there is, we're going to replace it with an underscore. If there isn't, we're going to leave it alone. Okay, so if we run that and then preview the data again, we'll see now it says acute underscore stress underscore disorder. So this is the new URL that's constructed for us. So what we just did is using this little paste command, we created 166 different URLs. That's a lot of URLs. Okay, we can use the from JSON command to read in one of them. And we'll be able to see that it's going to parse it for us into this nice data frame where we have by day how many views we had. This day we had this many views. This day we had this many views. It's all lined up very nice for us. Okay. I want you guys to go through the rest of this lecture during your time, during the rest of the week, so you can get some more practice with seeing what's going on here. But basically, the structure is we first went and collected information from a Wikipedia page. We collected all the elements that were list structures. We parsed them into one vector. We went to this other website where we were able to see page views. We constructed a bunch of URLs here that are taking advantage of the API we found on the Wikipedia page views site. Now what we can do is use those URLs to actually collect information. So here we have basically how many times this disorder was looked up on this specific day, right? You can try and estimate any models to see if there's some seasonal effects, for instance, in the patterns of people looking up different disorders, right? So like maybe people look up acute stress disorder before and after finals week, right? You can go through and you can actually test things now. The point is you can go through and put together all of these different tools to start building a little program to collect data for you. That's really what I want you to take away from this. Does that make sense? So even with something as simple as this like from JSON command, and with some curiosity exploring websites using the command line tools in your web browser, you'll be able to see lots of different information. Make sense?
Sense.
Okay. Now I'd like to take a minute and work on something a little bit different for us. So just save this, and I want you to open up a new R script, a blank one. Okay. What we're going to do is we're going to use a slightly different package called rvest. So if you don't have it, you need to run the command install.packages, and then in quotes write rvest. After you've installed it, run the library rvest to load in the package. Okay. What we're going to talk about now is getting more types of data. So we talked about collecting basically 3 types of data so far. We talked about, well, actually 4. One was using packages to get data for us, right? This was the easiest. 2, we talked about JSON APIs that exist on the internet that are like well-known and published and documented. Okay, one of them was like the Forbes API. Another one was the IEX Investors Exchange API, but now you have to pay for it. The third thing we talked about is reading in HTML tables and HTML lists. And the fourth thing we just talked about right now was finding hidden APIs or hidden JSON APIs using command line tools. Yes? Okay, there's actually a fifth way for us to collect data. And the fifth way is to actually just read and parse HTML tags. And you'll see what I mean by that in a moment. Okay. So far, we've really only leveraged collecting data from well-known published sources. What if we want to go to like a news website? So one website I keep track of is marketwatch.com. Okay, so if you go to marketwatch.com, you should get a website that, or a page that looks something like this. Okay, on this web page, here we see there's this latest news that's occurring, right? And it's streaming. So every time there's new news or new headlines that emerges, it automatically updates on the website, right? Okay. If we copy this URL and go back into R, we'll create a new variable called https://www.marketwatch.com. Okay, and for those of you that don't want to, there's the URL. Okay. We can use the rvest package to actually collect all of the HTML package, similar to how we did with the get request package. Okay, but we're going to use rvest this time. And the reason why is with rvest, we can actually go through and extract specific information on a web page. So inside of this rvest package, after you've loaded it in, you can create a new object. Let's call it HTML data. Okay. If we want to read in the HTML from a web page, we can use the command read_HTML. Then we can pass in the address where we want to read in the HTML from. Well, it's going to be from URL. Okay, so this is reading in the HTML from the website. Okay. Now, if we right-click on our web browser again and use our selector tool to highlight different elements, we can click on, let's say, this headlines tab. You see that?
Yes.
Okay. Here we can see that this entire latest news thing is actually an unstructured list, like we saw in Wikipedia. Okay. And inside of this unstructured list, there are list elements, LI, list elements, that have a specific class called latest news __ item. You see that? Okay. With the rvest package, we can actually parse through all of the HTML, all of it, and we can look up specific elements by their class name or by their ID. So here's what we can do. See how here it says LI, it's a list element and has a specific class, latest news __ item. if you copy this portion, latest news underscore underscore item, we can go back into R and we can say, okay, inside of this HTML data, I want to find the HTML nodes that are list elements of this class. Okay, there's a couple things going on here. HTML data is the rvest object that I collected all of the HTML into. What I want to do is go into the HTML data, and I want to look for HTML nodes. What I'm using here is called the pipe operator. What it's going to do is feed in the information from this first command into this second line of code. It's equivalent to me doing HTML nodes of HTML data and then looking up the item. Okay. But rather than passing in the object directly like I've done here, I can just write a pipe command using the dplyr package, which comes with rvest, to pass in the information from HTML data into this next function, which is HTML nodes. Okay. Why would I want to do that? Well, I can then pipe this information into another command. For instance, HTML underscore text.
Amazing. I saw people use this code online, but I was just wondering, it's basically just a stylistic thing because I could theoretically just have a really long line of code.
Yeah, you can write it like this. Same thing. These two lines of these two things are exactly the same thing. This line of code and this line of code are exactly the same thing.
Mm-hmm.
Okay, I just wanted to clarify.
Okay. So again, if you're having trouble with the typing or keeping up, let me send this to everyone in the chat really quick. Yes, it's entirely stylistic. Okay. But truth is, it's nicer, right? And that's the only time uni will hear me say that dplyr is a nice thing to use. Okay. If you take a look now, we have the actual latest news headlines from this website in R. Okay, the reason why I'm showing you this is I want you to know that there's this tool called rvest, and it gives you the ability through these two key commands, HTML nodes and HTML text, to look up specific elements inside of any HTML. It doesn't need to be a table. You can look up specific information and pull exactly that information that you'd like. Okay. Here's another example. Let's say I want to look up Orange County COVID cases or COVID update. Okay. Here's another web page by my county in Southern California. I'll send you guys all this URL. And we can see that there's information on here. Cumulative cases to date, 1,676. Cumulative deaths to date, 33. Cases reported today, 41. Deaths reported today, 1. Right? We can click additional data, and we can see there's even more information available here. Oh, actually, hey, what do you know? This looks kind of familiar to the Wikipedia page we saw, right? Okay. Nonetheless, let me send you guys all this link. We can take that same link, go back into R. We can define URL again, but now using this coronavirus and OC link. In our web browser, again, we can right-click on the web page. We can click Inspect. We can use our tool to look around and try and find the information that we want to extract. I know I'm moving a little quick. Am I losing you guys, or are you able to follow? Afra, are you okay? Dana, you okay?
Yes, I'm good. Sorry.
You good? Okay. So here I'm on that website. I'm using my inspect tool instead of my Chrome console. If I click on the deaths, for instance, I can see that this is an H1 tag. See that? Here it's a header of class, or it's a header of style 1. So it's basically the biggest font you can have on a website. What I can do is, using the same code I wrote before, I can copy it, paste it. Rather than looking up list elements, I can look up H1 tags. There's my H1 tags. Okay, I just sent everyone in the chat basically that information as well. This is what the Johns Hopkins team is doing. They're basically going to every county and they're getting the number of cases. They're scraping it. Okay, so here it's a little messy, right? But I know that the fourth element, because I actually saw the website, is the deaths. The fifth element is the cumulative cases, right? So what I can do is I can clean up this data a little bit more, and I can store it in a database, for instance. And every time I go to this URL, every time I run this code, it's going to get the latest data. Because every time I run this, it's going to the website, it's grabbing the latest information and showing me that information. Does that make sense? Same thing with these news headlines. So like, let's say I rerun that code from before. I can see if there's any new headlines. Nope, still the same. Summer is going to be a disaster, warns Trump advisor who compared lockdown protests to Rosa Parks. Okay, wow, that's absurd, but sure.
I have a question.
Yeah.
If I were to just grab the H2, that will just bring down the title, or will it bring? Oh,
So with H2, that looks like it's actually giving me some other information. It looks like, oh, sorry, I loaded in the wrong content. So if I do H2, it's showing me here everything on that website that has, yeah, showing me these titles: cumulative cases a day, cumulative deaths a day, cases reported a day, etc. Okay, and we can even really be a little bit more precise with the way we're scraping. So here I just did the generic H1, but really I could have said H1 of a specific class. Does that make sense? Or a div of a specific class. Like here's the class, panel, body, text, center. So I could have done something like H1 at class equal to, and then in quotes, put in that class. Oops, double quotes. And that would give me, oh no, what did I do? Oh. Wow, what's going on? Oh, it's not H1, it's div. Stupid. Like you can get very specific information if you'd like. So I know I'm moving a little. So here I went in, I didn't go into H1. So H1 is up here, or is a subset of this actual divider. And this div or container object has a specific class. The class is panel, body, text, center. So I changed the code from, rather than grabbing H1, I went up a level. And now I'm grabbing all of the divs on the website, or all the containers on the website, that have the class equal to panel body text center. So now it's not giving, it's actually just giving me all of the content I care about. But there's this additional, there's all of these ends in here. All of those ends are basically new line. So really what I could do is store info as all of this info. And I can go through and I can replace, using gsub, all of the new line commands with nothing. And then I'll get the clear, clean results. This stuff's all just going to take lots of practice, right? Here I'm just trying to introduce it to you as a general concept. But this is the manner in which you can grab any content on any website, pretty much, that doesn't require like a login or user interaction to render the information. This is a way to actually be able to pull pretty much anything. Okay, and this stuff's really useful in the real world. But this goes back to what Atusa was saying at the very beginning of the lecture. There's tons of data cleaning that needs to happen in order to actually like make this usable or useful. And the only way, unfortunately, you can get really good at that is just with practice. So I urge you guys to go to a couple websites and collect information. Okay? So we do have a little bit more time today, but to be honest, I don't want to start the next lecture already. The next lecture, I'll tell you about it a little bit before we, in advance of next week. But what we're going to cover next week is basically, it's just another regression. But the regression instead is we're going to focus on the cases where our dependent variable, our y, is a binary response variable. That is, it takes on basically two values, 0 or 1. So our interpretation then is going to be basically a probability. What's the likelihood of observing a y conditional on our observed x's or our observed independent variables? Okay, that's what we're going to focus on next week. And I'll incorporate it into the spatial stuff we're doing as well. So next week will be a meaty lecture. We do have some more time. Is there any questions on this stuff using RVest? I know I covered it a bit quickly.
Yes, sir. I have one.
Yeah.
Maybe I've been analyzing my data from the news source in period 1. Now I want to, the exercise we have been doing here is to get the latest news, so new data. Now, what control do I have to ensure that when I'm extracting this data, I get the same kind of format of data I used maybe in period 1?
You don't. So you have to try and write your code in a flexible way so that it can handle changes. Usually, most websites don't change their structures all that much. So like MarketWatch has been the same for almost 10 years. But that's something you run into all the time. So I write web scrapers all the time that break because they updated their website or the content changed on the website.
Yeah, sometimes it gives you different content. Yeah, okay.
Okay. How many of you guys are actually planning on using web scraping, do you think, at some point?
I think I have an idea as to how to, I can incorporate it into my project, the one that I have going on right now. So I think it'll be useful. But this is definitely a lot of the learning curve. It's pretty steep right now. So
Yes, of course. So what I always tell everyone, or in the lab I was a part of, right, the computational justice lab, I tell everyone, basically, if you want to write a paper, you need one of two things. You need either new data or a new method to publish a paper, period. You can get a home run, which is the combination of new data and you come up with a new statistical tool, like a new estimation method, and that gets you like an AER publication, a top journal publication. But basically, in order to write any new paper, right, you need to either have a new way of looking at old data, new tool, or new data using old tools, or some combination of the two. That's basically what gets you a good publication. Plain and simple. Using web scraping helps you get new data, right? You're not using the same data set that everyone's beaten to death and explored with 10,000 different regressions.
Thank you. I that definitely that puts things into perspective, I think.
Well, yeah, I mean, you guys are trying to, I mean, you're all in a PhD program or a master's program, right? You're going to be writing a thesis, you're going to be writing a dissertation. You need to have something new to say in your own way.
Yeah. And this is definitely a somewhat unexplored frontier, right? It's you know,
It's becoming more explored, right? So like when I did my PhD a few years back, no one was doing this stuff. Or like it was very rare. Now it's becoming a lot more common, I think. So like now it's expected. You know what I mean?
It's clearly very powerful.
Yeah, but you're going to need a lot of practice collecting data. I think I've written up an assignment in the past where I've had you guys, let's see. So in the past, when I taught the programming class last year, I believe I made everyone go and collect. Yep, all right, I have a problem set I can upload for you guys. Perfect. Okay, what I'm going to have you guys do is write a program to go and extract all of the information from the CGU website. So you're going to collect the directory, basically, of all of the professors in your department. Or if you want to be a really badass, you can go to every department and collect every faculty member. Okay, so I have an assignment I'll upload for you all that'll show you exactly how to do that.
cool. Thank you.
Any
Thank
questions?
you, Mason.
Nothing, we're wrapping up here. Come on. Okay, well, if anything comes up, email Uni or I. Ami, is she still here?
Yes, I'm here.
Yes, I've been seeing your emails, but honestly, I think Uni is smarter than I am, so I've been letting her take lead. Okay.
And will you still be having office hours this week?
Yes. Absolutely. Okay, everyone. So that's it for today. I apologize for not getting the assignment up last week. It'll be up today.
Thank
Okay.
you.
Take care.
Yep.